Welcome. This video series is going to continue to look at techniques of integration beyond the normal power rule and the use substitution that we've already learned. We're going to learn two additional methods in this video series. One is called integration by parts, IBP for short, and then the other one is going to be using partial fraction, so integration using partial fraction decomposition. And we're going to dive right in with integration by parts. And what integration by parts is going to allow us to do is undo the product rule. So we might remember that if we have a function that is a product of two functions, f and g, right, we can differentiate and do, 1d2 plus 2d1. And then if we try and integrate this, right, then we can do the integral of each piece, right? So, so we would, integrate this and this and this, all three parts. The integral and the derivative would cancel each other out, and then in the remaining piece, maybe we want to try and solve for one of the other terms that we could maybe do if this other integral is easily solved, okay? And so we might need to figure out, in our expression that we're given, do we have f times g prime, or do we have g times f prime? We'd have to, kind of play with that. But really what this is doing is giving us a formula for integration by parts, okay? Typically we express integration by parts using u and v's. So let's see, so what we might see is we might have u dv given to us, and then by integration by parts, which is really just integrating the product rule, we would have u times v minus v du. I remember this as uv is equal to, or sorry, u dv is equal to uv minus voodoo. I don't know, the voodoo just always sticks in my brain. Okay, and then just a note, if we have definite integrals, if we have bounds, we need to evaluate these expressions at a and b. Okay, and it would be very much like what we saw before. It would be, big F of b minus big F of a. Okay. And so then the question becomes, what is u and what is v? Much like u substitution, we might have to try a few things. But in general, there is a process in which we can select our u and v. And that process has a nice acronym. The acronym is affectionately called LIPET, L-I-P-E-T. Okay, and what it stands for is logarithms, inverse trig, polynomials, exponentials, and then trigonometrics. Okay, and with this acronym, what we do is we select u going from the top on down. So we first let u be a log if there's a log present. If there isn't a log, then we try inverse trig, and then we try polynomials, etc. And then we would select dv going bottom up. So try, if there's trigonometrics, let dv be that, otherwise exponentials, and then polynomials, etc. Okay, and so we're going to remember the integration by parts formula and also this acronym of LIPET as we move into examples in the next video.